So welcome back to the channel guys. Hope you are doing extremely well, and this is your very own mass coder this side. In this video we are going to discuss lecture number 17 of the linked list series, and in this video we are going to discuss the question remove linked list elements. So the question is simple. You have been provided with the linked list, as you can see, 1 2 6 3 4 5 6, and you have been given value as 6. You have to do nothing but you have to delete all the values of the linked list. Delete 6 here, delete 6 here, right? Delete 6 here, delete 6 here. The problem is actually simple, but through this problem I want to teach you a approach of dealing with the linked list series, and by using that approach the further questions of the linked list series will actually become very easy for you. So let us delve into the problem. Okay, so I don't expect you to, I don't want to explain the input and output because it is fairly simple. So let us move to the approaches again. Approaches, right? So approach 1. So I have got 1 2 6 3 4 5 6. First approach is I create a new linked list which will not contain these values. First approach is I create a new linked list. I create a new linked list, right? I create a new linked list. So what will happen? I will take my head, right? I will create a dummy node. I will create a head. I will create a node that list node star answer, right? List node star answer that is equals to null right now. I will keep a temp here. I will keep a temp here, and I will keep a temp at answer. Like, how will I insert? For that I'm saying. So answer is equals to null. That is answer equals to null. Nothing is present here. This is my answer position, right? I will start with temp. I will see temp's data is not equals to 1. So I will say if my answer equals to null, then my first node, that is my head node of the answer linked list, is 1. Insert 1 here, temp come here. Okay, now I want to insert 2 because 2 is also not equals to 6. So now my answer is here. Now I cannot remove this answer position from here. I cannot traverse with this answer position. Why I cannot traverse? Because I want to give the 1 as my head of the linked list. Because I want to give 1 as my head of the linked list. So what will I do? I will create another temp variable, and let us say it is a. Let us say it is A, and I will assign it to answer. That is A is also here. So A's duty is to traverse and add, and answer's duty will be to just keep the count of the head. What is head? Like it will point to the answer linked list head. Okay, temp is here. I want to add 2, so I will say A's next equals to new node, right? New node. What is the value of the node? Temp's value. So temp value, right? So it will add 2 here, and now because of traversal I will move my A to A next. That is A equals to A's next. A equals to A's next. Moving on, temp equals to 6, so skip it. Okay, moving on, temp equals to 3. Temp equals to 3, temp comes here, temp equals to 3, add it. A again comes to A next. Temp equals to 4, add it. A again comes here, temp equals to 5, add it. A again comes here, temp equals to 6, skip it. So at last you will see my answer linked list is 1 2 3 4 5, and that is exactly what I wanted as my answer. So that is not a problem. But what is the time complexity here? Time complexity is actually simple. I'm just using a traversal, right? I'm just using a traversal. So O of n is my time complexity. The space complexity is also O of n here. Why? Because I have created a new linked list, so which is actually taking almost O of n space, right? So that is not an efficient approach. The interviewer will ask you to delete these nodes in place. That is, do not use any extra space. In place. In place means that we have to do in constant extra space. We have to not use any kind of space, right? Now, how will I do it? So moving on to approach 2. Moving on to approach 2. What is my approach 2? My approach 2 says my linked list is 1, 2, 3, 6, 5, 6, right? Suppose this is my linked list. I have to delete 6. I have to delete 6. Okay, my head is here. My temp is here. I cannot move my head. You know that I cannot move my head because I want the starting of the linked list. So start moving with temp. Okay, my temp comes here. My temp comes here. I see 6 is not also here. Temp comes here. 6 is not here. Temp comes here. Now 6 is present. Let me remove the previous temps because that will create a confusion only. I have to delete this 6. Now we have studied about deletion of a node. What we will do? We will form this connection, right? We will form this connection, and we will delete this node, right? That is what we wanted to do. But we understood in delete also that we wanted a pointer right here. We wanted a pointer right here to do such task. Okay. So what will I say? With the temp, I will carry a previous pointer as well. So I will say my previous, when my temp was at head, my previous will be at null. Temp was here, previous will be here. Temp was here, previous will be here. Now temp is here, previous will be here. What will I do? I see temp's value is equals to 6. So what will I say? Previous next is equals to this next. So I will say previous next is equals to next. I will assign a temp's next equals to next, and then previous next equals to next. Now what will happen after deleting this node? The linked list would look something like this. The linked list would look something like this. 3 connected to 5. There is no temp now. So what do you have to do? 3 is done. You have already explored 3. So temp will come to next. So I will say t equals to next. That is temp equals to next. So t comes here. Previous will remain same. Please mind it, in the previous operations when temp was not a part of, while my temp's data was not equal to the value, previous was also traversing, previous was also coming afterwards. But in the case when I'm deleting a node, previous will remain same, because it might be possible that it is something like this: 3 connected to 6 connected to 6. So when your temp is here, your previous is here, you delete this node, your connection becomes like this, and your temp comes here. Now if you want to delete this node as well, you will have to keep your previous here. So I will not shift my previous here, right? I will not shift my previous here. This is for if case, and else case I will shift my p also. So p equals to p next, and temp equals to temp next. Temp equals to temp next, right? All right. So this connection is formed. Again p t. Again this. So I will keep an n here, change it here, and t will become null. So I will run out of the loop, and I will see 1 2 3 5 is my answer. 1 2 3 5 is my answer because I deleted this node, right? 1 2 3 5 is the answer. So okay, so how will I upload, how will I do the coding of this? So I will say that p equals to null at starting, temp equals to head, temp equals to head. Okay, now what I will do, I will do while my temp is not equals to null. My temp is not equals to null. What do we do in that case? If my temp value equals to the value I want, that is I don't want the value 6. So if temp value equals to value, so we discuss p is next is equals to temp next, and delete your temp value, delete temp, and after that p is next, oh sorry, temp equals to, it will be temp equals to p next. Remember, I am not traversing my p here. I am not traversing my p here. Else what will you do? You will say p equals to p next and temp equals to temp next. The normal traversal will carry on. The normal traversal will carry on. Okay. The problem with this is it will not handle the cases of 6, 6, 6, 5, 3, 6. When there is a node 6 which I don't want is at present at the head position, what will I do in that case? Because my head is here, after the deletion of the linked list, what will look like? My answer linked list would look something like 5 3, right? My answer linked list is 5 3. So you can see my head is getting changed here. My head is getting changed here. So I will have to deal that separately, because you already know whenever your head is getting changed, you will have to deal that thing separately because you want a reference to the head. So what you will do? So it is commendable that before starting with this loop, I will first check for the head value. So what will happen? I will say while head value equals to value, what will I do? I will say x equals to head, head becomes head next, head becomes head next, and delete your x, delete your x, right? Okay, now you can see what will happen. 6 is the value, I will say assign x to it, move head here, and then delete it. Okay, again 6 is the value, assign x to it, move head here, delete it. Again 6 is the value, x here, h here, delete it. Now you can see I am assigning 5 3 6 to this loop now, and this will run fine, this will run fine. But I'm saying that you are actually using two loops, and you are actually complicating your code, right? This approach is also fantastic. There is nothing wrong in it. It is using O of n time and O of 1 space. It is perfectly fine. An interviewer will be happy with this approach. But I am saying, can you optimize it? Can you write a cleaner code? See, optimize is done. Optimize is done. You have optimized the problem. Optimization is not a problem now. Optimization is achieved. I want to write a cleaner code. I want to write a cleaner code. So how will I do that? And this approach will be, which I'm going to write in the cleaner code, which will be used in the future references, where writing that optimization code which we wrote above is actually very difficult, right? So what I'm saying is I have got the linked list 6, 5, 6, 4, 3, 2, 6. Suppose this is my linked list. I want to delete 6. What will I do? I will make a new node. I will make a new node and tell it as dummy node. I will make a new node, dummy node, assign any value to it. Let's suppose you make a dummy node of value -1. Okay. So you do have this dummy node, right? Keep a temp here. Keep an traversal here. So A here and temp here. Now what I will do? My approach says -1 is here, temp is here, right? If temp value, I am saying if temp value is equals to the value I want, value I don't want is equals to value. So 6 is that case, right? So what I will do, I will say that temp, I will delete the nodes, x equals to temp and temp equals to temp next and x, delete x and delete x. So what will it do? It will assign a x here, temp will come here and delete it. Okay, no problem. But if it is that, if that is not the case, that is else case, what will I do? I will say a is next is equals to temp. That is form a connection something like this. Form a connection something like this. Okay, done. Then a equals to a next, a equals to a next. A will come here at the position of temp. Okay. Temp equals to temp next. Temp equals to temp next. That is temp will come here. Now a next is equals to null. That means break this connection. Break this connection. Temp is not here right now. Okay, so you have actually attached -1 with 5. So your linked list is looking something like -1, 5, right? Temp is here. Again, because of the traversal, temp will move again. 6, again a value. So what I will do, I will assign t here, x here, delete it. T equals to 4. I will have to do something. So 5 will get attached to 4 and t will come here and a will come here. So it will be something like 4 null, right? And t is here. So this is not a part now. 3, 2, 1. 3 here, 2 here, and at the time of 6 it will not get inserted again and my linked list will look something like null. The step for this, that a next equals to null, was actually to achieve this. Okay, nothing else. Was actually to achieve this null at the end without any more hustle bustle. Okay, so null is achieved here. Now you can see my head is actually 5. I want my answer as 5, but my head is actually my dummy node. Now it is very easy to delete a dummy node because it is front. So delete at front will be operative. I will say x here, head equals to this, and delete your x. And you will see 5432 is the answer we wanted and 5430 is the answer we get. So let me write down the pseudocode again. What I have done is I have said dummy equals to new node with value -1, let's say. Okay, a equals to currently pointing to dummy. Now what will I do? I will say first temp equals to head, temp equals to head. Now while my temp is not equals to null, in that case what will happen? I will say if temp value is equals to the value I don't want in my linked list, in my answer linked list, in that case x equals to temp, temp equals to temp next, delete x, right? Moving on, if that is not the case, that means I have to add it. So else what will you do? A is next is equals to temp, temp equals to temp next, a equals to a next, and now change a next to null. A is next equals to null. A is next equals to null. But the work is not done yet because after getting the whole of the linked list, I will have to delete my dummy node. So head equals to dummy next, delete your dummy, delete dummy, and you can safely return your head. Return head, and this will work absolutely fine and it should not give any error, right? So let us try to run it. Whether what is the space complexity here? It is again over 1. We will be saying that you are using extra space, but that is constant, right? I'm using one node extra space. I'm not using a whole linked list. So space complexity is again constant. Time complexity is over n, right? The reason for writing this code is to introduce you to the dummy approach, which is quite prevalent in the linked list. So you will see that in the further lectures also. Dummy approach is a quite important approach. And second thing, cleaner code, right? Because the interviewer always likes you to see a cleaner code, right? So I hope that do you understand? So let us move to the codings area. Alright guys, so here is the coding section. Before starting to write the code, I would like to request you to please subscribe to my channel because you know it is taking a quite lot of effort to make this playlist and etc. So please show some support and let us now start writing the code. So list node star dummy equals to new list node, as we discussed, right? To keep the reference of it. Now, for traversal, make a new node A, which will be pointing at dummy, and similarly temp will be pointing at head. Now moving on, while my temp is not null, in that case what will happen? Two cases can occur. If temp's value is equals to my current value that I want, that I don't want. So in that case, list node star x equals to temp. Move temp a little step forward and delete your x. Delete x, right? No problem. Else, that means I will have to add this node. So what will happen? A's next is equals to temp. Temp move forward, temp equals to temp next. A equals to A next. And now A's next will now be equals to null. Right? Now I just have to delete my first node of the answer linked list. That means my list, my head will be now dummies next. And you can safely delete your dummy to free the memory. So delete dummy and you can just simply return my head. It will work fine, I guess. Let us try to compile and run it. Should not give any error. Oh, this is giving an error. What is the error? Let me see. So I've got the error. I have not traversed my temp. Okay, typing mistake. Let us try to compile and run it now. Hope it will work fine. It is working fine. Let us try to submit it as well. And it is running fine. Okay, so thank you for watching and we'll meet tomorrow with a new question, with a new lecture, and please stay tuned and please consider subscribing to my channel if you have not yet subscribed. Okay, have a nice day. Bye.